Baby, you are strong, you are wise, you are worth.
Hello. So I decided to since Siso Sharma number pattern sequences in series is what we do. I'll quickly go to the only time I'll go to grade 11 is if there's a need for you to know some of the stuff from there, right? Because now since you're saying you're writing like May, June, we don't have time at all, so we must use whatever time to finish chapters as quickly as we can. But that's not the aim, of course, to finish without understanding, but we must try to push as much as we can, right? So, and we can only be able to do that if we work together so that we get things done faster. So, what I need from you, if there's something you don't understand, anything that I mentioned in the video, be quick to tell me. Don't tell me after a week or so, right? Because I want us to be fast, and I also have things to do on my side, right? But that doesn't mean we won't get things done. So as you can see there, we'll be doing the first chapter in Maths Grade 12. It's number patterns, the sequences in the series, right? So what I'll quickly do is quickly to go back to grade 11, right? Just one sequence that we have to know from grade 11 that is important, right? Which is the quadratic sequence. So obviously in grade 12, they won't teach you this year because they expect you to know it from last year, right? So the quadratic sequence, what is important here is that the second difference, right? The second difference has to be constant. I'll just write the second difference has to be constant. I won't write down everything I'm going to say because of time, right? And I don't want the videos to be too long for data and stuff, right? So just keep it them a bit short. If they are long, they'll be 1 hour, right? But anything from 20 minutes to 1 hour, yeah, not more than that. So the second difference is to be constant. So what do we mean by the second difference being constant? If we remember well, we are used to these patterns from early grades, right? These are the patterns we are used to. If they give you a sequence like this one, we have 2, 4, 6, 8, 10 until Jesus comes, right? So what you would have here, the difference would be, you'd see that it is 2. They keep on adding 2, they keep on adding 2, they keep on adding 2. So we can see that this is the first difference. We call this the first difference because the first time we wanted to get how they get to the next 10, we found the constant number, which is 2. So we call it the first difference, right? But it happens that you have situations whereby you don't have the first difference being constant, right? Whereas you have the second difference being the one which is constant. So in those sequences where the second difference is the one which is constant, we call those the quadratic sequence, right? So you won't be given this in an exam, it's too easy, right? So they will give you something of this nature. Let's assume we have -1, and then it's followed by 6, it's followed by 15, and then the next term is 26, the next term is 39, until Jesus comes, right? So the first thing that we have to address, we will represent the second difference. Okay, we will get to the point. Let's do this first. So we can see here that from here to here, they added 5, right? Did they add 5? No, right? They added 7. Right, so from here to here, we can see that they added 7. And then from here to there, we would expect them to add 7 because if we say 6 plus 7, that would give you something like 13, whereas we have 15 here. So the difference here is instead 9, right? The difference is 9. And then from 15 to 26, they added 11. And then from 26 to 39, they added 13, right? So you can see that the first difference, which is all of this here, it's not constant. So we will try to take it even a step further so that we find a constant number. So from 7 to 2, from 7 to 9, they added 2, right? From 9 to 11, they added 2. From 11 to 13, they also added 2, right? So we can see that they've been adding 2 and adding 2. So this is the constant one, which is 2 and 2 and 2. So this is what we call the second difference, right? This is the second difference. So why do we call it the second difference? Because this was the first difference here, but we can see it was not constant to get 7, 9, 11, and 13. But the second time when you try to find the difference from the first difference, not from the original equation, we found that the difference is constant. So we call this one a second difference. So hence we are saying that the quadratic sequence is a sequence whereby the second difference has to be constant, right? So from here you will be expected to find what we call as the general formula. So what is the general formula? The general formula is simply the formula that you'll use to find the next terms. So what are terms? This here, this -1, it's the position, right? So this is in position 1, we call it term 1. This is term 2, this is term 3, this is term 4, and this is term 5, right? So terms are simply where we can't say 39, we can't say 26 and whatever, because they can change, right? So we want something that is constant. So we use terms, right? So term is simply the position, right? Simply the position. This is still term 1, term 2, term 3, term 4, and term 5, right? So if they can say to you, we want, let's say, for example, term, this is term 1, 2, 3, 4, 5. If they say, for example, give us term 6, right? For you to be able to give them term 6, you must first add here. Let me try to erase it. So you must try to add here first, right? So we can see that we've been adding 7 from 7, 9, 11, and 13, right? So since this 2 is constant, we know for us to get this, the next term, we must add 2. So what is 13 plus 2? That is 15, right? So then what is 15 plus 39, right? And then that will help us to find the next term, right? So 15 plus 39, that will give you something like 54, right? So you will be having your next term as 54, right? But you can't keep on doing this. Let's assume for whatever reason they say give us term 99, right? You can't do this until you get to term 99. So that is the importance of having a general formula. So your general formula comes with this format, right? Tn, and I told you that n is what? N is your 10. Since they wrote T99, it means 1099, right? So Tn is just your general formula, right? Or your rule from the early grades, you know it is the rule. So this is it. It is an squared plus bn. If it happens you forget the formula, it's okay, right? But I wouldn't advise you to, okay, let me not say I wouldn't advise you to, because it's not like you decide to forget, but it will be given in your formula sheet, right? So this is the formula, right? So from there, we must then dissect the meaning of each letter here. We already said Tn is general formula, N is your term, A, I will show you, A is the second difference here, right? Because when we are doing the series and the when we are doing the geometric and the arithmetic, A will change. But for now, just know that A means the A here is the second difference, right? I just write second difference, right? And then B and C are your constants. So B and C are your constants. So what I want us to do now is to try and apply this formula and find the general formula of this sequence here, right? And find that sequence there. So we can see we had something, let me try to erase so that we have a clean board. So I hope you can understand me so far, but if not, let me know. So here, before we continue, what you have to know is that this part, the whole of, if you can notice, we now have about 3 sequences. We have the first one here, the second one, and the third, right? So what you would do, you take it always on the first sequence, it will always be A plus B plus C. It will be equal to the first term. I repeat, this A plus B plus C, that one you must know because you won't find it in your formula sheet. They won't give you that because they'll be giving you the answer. And then the second one, it will always be 3A plus B. And then the third one will always be 2A. So you must know this. 2A, 3A plus B, and A plus B plus C. And the only way you know that is by practicing, right? So we always start here going up. We always start here going up. So meaning always the first value that we will get is A, right? So you say 2A is equal to, I told you that you always equate it to the first term. So we can see the first term is 2, right? So it's 2 and you divide by 2, you divide by 2, right? Your A will be 1. So now we are looking for B. We have A. You come to the second one, right? You are done with this one. You come to this one. Why are we starting here? Because we only have one variable here, which is A. So that is why we are starting here. We can't start here because we have nothing, right? It will take us too long. It will take us time, right? And then we have 3A plus B being equal to the first term, which in this case, our first term is 7, right? And then we have 3, you substitute A, which is 1, right? It means if your A is incorrect here, everything that you write here will be incorrect. So we substitute that 1, it is plus B, it is equal to 7. So 3 plus B, 7, right? So it's B, 7 minus 3, that's it. You take this 3 to the other side, it will be minus. So it's 7 minus 3 that will give you 4, right? So we have our B, we have our A. So we come to this one, right? So when we come to that one, it is A plus B plus C. It is equal to the first term, which in this case is -1. So what is our A? Our A is 1. What is our B? Our B is 7. And what is our C? What is our C? Our C is the one we are looking for, right? Is the one we're looking for. So that is equal to -1. So when you add these two, they will give you +8. You take +8 to the other side, it will be negative. So C will be equal to -1 minus 8, which will give you something like -9. So we now have our all 3 variables. We now have all 3 variables, right? So our 3 variables, we'll just plug them in this formula here, right? We'll just plug them in that general formula, right? But you have to write it first. So you write this down as it is, that Tn is equal to an squared plus bn plus c. Get you 1 mark for knowing the right formula to use. Then from there you substitute, right? So n must remain the same. So it will be Tn, it's equal to, what is your A? Your A is 1, right? So we can't put 1 there, right? We write it as n to the power of 2. And then plus b, our b is 4, right? So we just write plus 4n, right? And then our c is -9, and then we just write -9, right? So this is our formula, right? This is the general formula. If they say find the general formula, this is the formula they want, right? So then it means from here, what we can do is simply, it's 4. Oh, guys, we made a mistake here. Our B is 4, it's not 7. I don't know why I it's 4. It's 4. Sorry. It's 4, right? So 1 plus 4, that will be 5. 5 to the other side, it will be 1 minus 5, which will give us negative. Okay, this will be -5, and it means this will be -6, right? So it means here we will have -6. Sorry for that. We have -6. So this will be your general formula. So then it means since they wanted to find term, okay, you would check afterwards, right? But right now we won't check, right? What do I mean by you checking? I mean, you would say, let's take 10 2, for example. If we put 2 here, 2 squared, that is 2, that is 4. right? And then 4 multiplied by 2, that will give you 8. And then minus 6, this is 4 plus 8, it gives you 12. So 12 minus 6, it's 6, right? So you can check with the other terms. But let's say, for example, they say find 1000. So you say T100 is equal to, you substitute. You would have to write this first, obviously, get you 1 mark, and then you substitute. Wherever you're seeing n, you'll be putting 100, right? Plus 4 multiplied by 100 minus 6, right? So it will be 100 squared plus 400 minus 6, and then you find your answer there. It's that simple, right? So I just wanted you to remind you a bit of about that thing. So let's take another quick example, and what I'll do, I'll just give you maybe 5 more, or if you understand, then you let me know, and then I'll give you maybe 5 more, right? So let's take, for example, they tell you to determine the algebraic expression, right? That represents the nth term. So sometimes if they don't say to you, find the general formula, they say to you, give us or find the nth term, right? So they say general formula or nth term, it's one and the same thing. So we have 4, we have 7, we have 14, and we have 25, right? So that is your sequence. And you don't know at this point that it is a quadratic sequence, right? So what you do, you find the difference, right? So the difference here would be 3, because 7 minus 4 is 3. What is 14 minus 7? That's 7. What is 25 minus 14? That is 11, if I'm not mistaken, right? So from there, this is your first difference. What is your second difference? 7 minus 3, that is 4. 11 minus 7, that is 4. So we can see that our second difference is constant. It means that this is our quadratic quadratic sequence, right? So how do we come about to solve it, to find the nth term or to find the general formula? Remember, I told you that here always it will be 2a, here always it will be 3a plus b, and up there you have a plus b plus c. Right? Don't worry where this comes from. They won't ask you to prove it. So our 2a, and I always told you that we start from here going up. So our 2a will be equal to the first term, which is 4 in this case, right? So we divide by 2, we divide by 2. Are we dividing by 2? We are trying to eliminate that 2 so that we're left with a. So our a will be 2, right? Done. And then we, oh, Jesus. And then from there, what do? We continue. Now we want b, but we have to write 3a plus b. It's equal to the first term being 3 in this case, right? So our 3, our a we already know it's 2. We substitute 2 plus b, it's equal to 3, right? So what is 3 multiplied by 2? That is 6, right? 6 plus b, forgive me for the handwriting, 6 plus b is equal to 3, right? So your b will be equal to, it will be 3 minus this 6, giving you negative 3. So we have b, we have a. So now we want to find out, we want to find c, right? So it will be a plus b plus c being equal to the first term, in this case being 4. So a, we already know it's 2, b, we already know it's negative 3, right? So we just write minus 3 plus c, it's equal to 4. But we know that 2 minus 3, that will give you negative 1. Take negative 1 to the other side, it will be positive 1, right? So you see will be positive 5, right? So when you write down the whole thing, let me now erase it because we're done. When you write down the whole thing now, you'll be writing it in this format, right? You start with the general formula. Tn is equal to an squared plus bn plus c. Get your mark for knowing which formula to use. And from there, you simply substitute, right? So your a will be 2. So we'll be having 2n squared. Then your b is negative. Take the signs, they are very important, right? Just because they have positive here and we have negative, what that positive is simply saying is take b with its sign, right? So we can see it's negative 3, right? So it will be negative 3, and then c will be plus 5, right? It's that simple. You are done. You are done. So that is what I wanted you to know from grade 11. I'll give you exercises, but if you feel like you don't need them, you still remember the stuff, it's okay. We'll move on, right? So let's quickly go to content of grade 12, what you will learn in grade 12, right? We have arithmetic and we have geometric sequence, right? So I'll touch on them a bit. We have arithmetic and geometric sequences. So obviously at this point, you know that a sequence is a set of ordered numbers. And as I just told you that we have two types of those sequences that we'll cover in grade 12, being the arithmetic and the geometric sequence. So what is the difference between the two? The arithmetic sequence is a sequence in which the difference between any two consecutive terms is common, right? So what we are basically saying is that in arithmetic sequence, the first difference is constant, right? The first difference is constant, and that difference we denote it as d, right? But in geometric sequence, we don't have a difference. Instead, we have what we call a ratio. So the ratio between two consecutive terms is constant, and we denote it as r, right? So in arithmetic, we have a sequence, and in arithmetic, we only use it for positive, for adding and subtracting, whereas geometric, we only use it for multiplication and division, right? So that is why we call this a ratio and we call this one a difference, because you can't say you have a difference, because difference simply means minus, right? So the first term of the sequence, which we denote as T1, it will be our A, right? I told you this is not the same as the quadratic sequence. In quadratic sequence, A represents the second difference. But in arithmetic and geometric sequences, A represents the first term, right? Don't get that confused, right? And then we have the geometric, we always have the arithmetic and the geometric formula, just like we had the general formula with the quadratic sequence, right? So A is the first step. The difference, we use D, and the ratio we use R, right? Don't get that confused. So here what you have to know and what you have to remember is that for arithmetic, this is the formula. And then for geometric, this is the formula. Easy. Don't get those things confused. Easy, easy, easy. Right? So we'll note those two down, then we'll just do a few more examples. So let's start with the one of arithmetic, because it's the easier one, right? So let's take, for example, given a sequence like this, and you are told to find the 10th term, right? So you are told to find 10, 10, right? They want to find 10, 10. So for you to find 10, 10, you must first find out what the type of the sequence is here. So obviously, if you can see that from here to here, they added 7, right? You can see that from here to here, they added 7, or we can say 12 minus 5 is 7. And from here to here, they also added 7. So it means our D is 7. It's the constant. And our A, I told you that A is the first term. What is the first term? In this case, it's 5. So your A is 5, right? So your N will be 10, because they want 10, 10, right? Easy. So since we know that it is an arithmetic because the first difference is the one that is constant, it means the formula that we'll be using is this one, because this one only applies in arithmetic, right? So from here, what you simply do is to substitute. We want 10, 10. What is A? A is 5. Plus, what is N? It's 10, right? Minus 1. What is D? D is 7, right? So what is 10 minus 1? That is 9, right? So we'll be having 9 multiplied by 7 plus 5, right? That should give you 10, 10. So what is 9 multiplied by 7? That should give you something like 63, if I'm not mistaken. And then 63 plus 5, that will give you 68, right? So it means 10, 10 will be 68, right? It's that easy. And you can reverse the whole thing, right? You can reverse the whole thing. Let's assume instead they gave you that formula, but instead they told you that 68 is the term, right? They told you to find out which term is equal to 68. So what they are looking for now is n, right? So let's assume we don't have that one, right? But what we have instead is that they tell you that Tn is 68. They want you to find n, right? So you would do the same thing, right? You would do the same thing. A plus n minus 1, sorry, n minus 1 multiplied by d, right? So you substitute on Tn, you would put that 68. Your A is your first term, still 5, plus we don't know n, that's what you're looking for. The difference is 7, right? From here, what you do, you take this 5 to the other side. So it's 68 minus 5. Why are we taking that instead of taking this? Because this is 110. All of this is 110, right? So you can't separate that. So this 5 goes to the other side. We'll be having 63, right? So it's 63 equal to, then you take this 7, you distribute. 7 multiplied by n, that's 7n. 7 multiplied by negative 1, that is minus 7, right? So from here, what you would do again, you take this negative 7 to the other side, right? So you'll be having 63 plus 7 giving you 70, then it's equal to 7n. Then you divide by 7, you divide by 7. Your n will be equal to 10. You're done. It's that easy. Don't complicate things. I hope that makes sense. And then from there, let me give you an example of geometric, right, to show you how they differ. So let's assume that you're given something of this nature. Right, so from here you can see that, okay, you can say they added 4 from 2 to 6, but when you add 4 again, it doesn't give you that same number. Right? So let's say you say they added 4, and then here you say they added 7, right? They added, no, they didn't add 7, they added from 6 to 18, they added some 12. Yeah, they added 12. So from here to here, and then we say it's 6. You can't use this if you're given 3 terms, right? You can't use this if you're given 3 terms because you can't say the difference is constant because we want to see if it will still be 6. We want to see if it would still give us 6, right? So let's assume that they also gave you the next 10. Let's just assume that they also gave you the next 10 being 54, right? So from 18 to 54, you would notice that the difference is 36, yeah, 36. So from 12 to 36, you notice that the difference is now 24, right? It's now 24. So you can see that is not the same. So it means this can be the quadratic, right? So if it can be the quadratic and it can be the arithmetic, so what is left for us to find is that it is what? It is a geometric. So what then is a geometric sequence, right? Geometric sequence, we said it that it is the one where the ratio is the same or the ratio is common. And we said we only use it when multiplying or dividing. So from here to here, if you can say 6 divided by 2, so you can, if you remember, we found the difference by subtracting term 2, by subtracting term 1 from term 2, right? On the previous example, I don't even remember the exact, so let's assume we get something like this. For you to find out the difference, you'd say second difference minus the first one. It's 10 minus 5. And that should be the same as the third difference minus the second one, right? So the third one is 15, right? So 15 minus the second one, which is 10. So this is 5, and this is also 5. That is why we are saying the difference is constant. That is the formula for finding the difference. D is equal to T2 minus T1. But for finding R, which is a ratio, it is the other way around. It is 2 divided by T1. 2 divided by T1 should be the same as T3 divided by T2. Right? Get these two formulas, this one and that one. We'll pause the video and write them down. So let's move then. Let's move and see how is that helping us. So when we get there, you can see that from here to here, if we say 6 divided by 2, the answer will be 3, right? And if we say 18 divided by 6, the answer would still be 3, right? So it's constant. We are happy, right? It's constant, we're happy. But if there were other times, I would advise you to do at least 3 times. 1, 2, and find a third one, because there are other patterns which are tricky. We will do that as time goes on, right? So it means now that we have R and we don't have N, it means the right formula to use now is this one, AR to the power of N minus 1. And this N minus 1 is only for R, it's not for A. I repeat, this N minus 1 is only for R, it's not for A. So when we substitute, your A is still your first term, which is 2 in this case. Your R in this case is 3, right? So we want to find, let's say, for example, the 6th term. We want to find the 6th term. So 6th term, we understand that it is the same as this. It can be written in that way. So T6 is equal to, what is your A? Your A is 2. And what is your R? You put it in brackets always. It's 3 to the power of, what is N? Our N is 6, as you can see here. So it's 6 minus 1 giving us 5, right? So it's 3 to the power of 5. And then the answer you get, you multiply that by 2, right? So 3 to the power of 5, that should give you 243 or something like that, if I'm not mistaken. 243 somewhere. You verify with your calculator. So it's 243 multiplied by this 2. That is what term 6 is. So term 6 is 2 multiplied by 243, which is 486. That is the correct answer. Right? That is the correct answer. Easy. So these things are simple. What I want you to do is to watch the video. Let me know when you're done, so that I give you 2 or 3 example activities, and then you do that, and then we move on, and then we also do the challenging part, right? Thank you. That's it from me for this video.